Okay, so this is another metallic bonding question. This is looking again, structure and bonding, but this time looking more at the bulk properties as to how they can be bent and shaped as we would imagine a metal can be done. And what we need to look at is just the more generic structure. Don't need to go into the structure and bonding of electrons and stuff like that, as we just had in the previous question. But again, if we just quickly draw the regular arrangement of particles that we expect to see in a solid, we have this regular arrangement. And it's this regular arrangement which gives the metals, their bulk properties. And the key part to it is, as you can see, is the layer structure. What we've got is these planes between the atoms. And because even though metallic bonding is a relatively strong bond, as we've already discussed, it's not the highest bond strength, and the bulk properties allow these layers to slide. Okay, they allow them to slide over. Imagine if you had piles of pieces of paper, you can slide the top layer off and just move the sheets around. The sheets themselves are quite strong, but the actual layers themselves can all slide apart. So you can imagine if we had a bulk piece of this metal, we could draw this into a wire by pulling the top layer to the right hand side, the bottom layer to the left hand side. It would make that piece thinner but longer. Okay, so to get the marks then for this question, which is just 2-mark question, the key point is we're looking at a layered structure. Okay, and the layering of this. So in a kind of similar fashion, again, not identical situations, but like graphite. Okay, that's got a layered structure, and the layered structure, it allows them to slide over each other. Okay, so we have the layered structure which can slide over each other, giving it this stretchable property and various keywords like being able to bend and shape the thing, and things you might learn in other subjects such as DT, for example. So what we can then do though is look at alloys, which are obviously a much stronger version of a metal. And what they are is there's a metallic structure, but usually with always with a different element within it. Okay, and the question is asking us then, so why is it easier to change the shape of a pure metal in comparison to an alloy? And the key thing here is that it's the mixture. Okay, the key thing is because we've got different elements in it, the circles, if you imagine the diagram we've got on the top again, is if we have different elements, what we've got is, now I'll just superimpose it, but we can put a different element in here, which is fundamentally of a different size. Okay, so we have different elements of different size. And it's this different sizes that gives us the key property of an alloy, which makes it harder. What then happens is that then distorts the layers. Okay, it distorts the layers. And what that means is that, for example, this top layer is now bent or is forced out of the straight line, which gives us the sliding property of the previous one. And basically, the orange piece in the middle gets in the way. It distorts those layers and ultimately just makes it harder for the layers to slide. And once those layers are struggling to slide over each other, it makes the alloyed mixture much harder. Okay, so just harder for them to slide over each other.